For a completely long term, people have imagined what life may be like on different worlds. Thanks to the James Webb Space Telescope, the most effective telescope in life, we are able to finally begin to answer that query. While looking at Proxima Centauri, the closest star system to us, only 4 light-years away, scientists have observed peculiar anomalies from one of the planets inside the system, Proxima B. These anomalies, referred to as artificial lighting fixtures, have confused the best minds within the scientific community. What are they, and do these lights endorse the lifestyles of sensible life on the planet? Join us as we explore James Webb's terrifying discovery of metropolis lighting fixtures that modifications the entirety we recognize approximately life beyond Earth. The best life we're presently aware of is on Earth. Since the beginning of civilization, humans have wondered whether there's life somewhere else within the universe. To carry out interstellar seek, American astronomers Jill Tarter and Thomas Pearson launched the search for extraterrestrial intelligence set a task in 1984. The nonprofit's objective is to accumulate spaceborne radio alerts. Radio waves can journey farther and are, therefore, much more likely to be detected through the 42 radio telescopes that make up the unique Allen Telescope array inside the Californian Cascade Mountains. However, in the past 30 years, no verifiable alien signal has been determined. After that, the James Webb Space Telescope's successful launch aided in the quest to study various undiscovered planets orbiting some distance off stars. The largest telescope within the world, floating more or less 1 million miles from Earth and geared up with highly sensitive detectors, may be used to search for symptoms of lifestyles beyond our solar device. 2 decades ago, there were no acknowledged planets outside those in our solar system. Considering then, more than 4,000 exoplanets have been found orbiting different stars. According to NASA, the universe may comprise trillions of exoplanets. The earliest signs of life beyond our sun system can be discovered in extraterrestrial flora. For instance, the Galileo spacecraft turned its devices back toward Earth on direction to Jupiter and located a precise indication of the presence of flora. The tool detected the flora's crimson facet, a biosignature, a mix of pink and infrared lighting reflected by way of flowers. The JWST will measure the visible and near-infrared VR of some distance off Earth-like planets in the habitable region around stars. They might be important signs of lifestyles inside the exoplanet surroundings. When sunlight crosses a planet star, the JWST can be capable of hit upon it as it enters its atmosphere. The lighting fixture's missing wavelengths would then be observed through spectroscopy. Atoms and molecules inside the atmosphere soak up particular wavelengths, creating a characteristic fingerprint that the JWST can apprehend. This technique may be used to decide the composition of the surroundings and whether or not lifestyles are possible. Life ought to exist on the planet-sized planets with atmospheres just like our very own, with a predominance of oxygen, nitrogen, and carbon dioxide. By looking for factors that are not typically present, one can be in a position to discover technological life. Chlorofluorocarbon, CFCs, generated for use in refrigeration and cleaning merchandise, could probably be considerable to aliens monitoring Earth's surroundings from a distance. If the JWST observed CFCs in planetary atmospheres, that might be a clear indication of civilization. Life on exoplanets might not even remotely resemble existence on Earth. Sometimes even earthly life like extremophiles, species which could bear in environments wherein different residing matters might perish, can seem alien. This is a group of organisms, usually bacteria, which can resist extreme situations. Because planets like Earth are more likely to support existence than planets with excessive temperatures or acidic conditions, it will be a great concept initially those first. A high candidate may want to have temperatures that permit liquid water to exist on their surfaces and orbit a strong superstar. The type for our Sun is a yellow G-kind famous person. Those stars are less not unusual and typically have shorter lives. However, in our universe, the likelihood of reading planets orbiting round red dwarf stars, which are more frequent and have decreased luminosities and temperatures than the James Webb Telescope, Sun, is better. There is more time for the formation of life and evolution to produce complicated lifestyles bureaucracy. Approximately 40 light-years away from Earth, the TRAPPIST-1 planetary device could be the subject of JWST's first assignment. It revolves around a calm red dwarf big name with 7 Earth-sized rocky planets. 3 of which are in the so-called habitable area and may have liquid water on their surfaces. The TRAPPIST-1 celebrity, regardless of having a miles smaller and chillier mass than our solar, radiates mild. This is much like that of Earth due to the close orbit of its planets. The fine risk for humans to look town lighting fixtures out of doors. The solar machine is Proxima Centauri, a pink dwarf megastar that is 4.15 mild-years from the Sun and our nearest famous person. Proxima is set 600 instances fainter than the Sun, so a planet ought to be 20 times in the direction of it than Earth is to the Sun. And as we delve deeper into the cosmos, the James Webb Space Telescope gives us a completely unique window into the formation of galaxies, stars, and planetary systems, hard our knowledge of the universe. Among its many objectives, Webb seeks to answer essential questions about the life of lifestyles past Earth, examining the atmospheres of exoplanets for signs of habitability. The precision of Webb's gadgets lets us examine the first lights of the universe, giving insight into the formation of the very first galaxies. By analyzing the chemical fingerprints discovered within the mild of distant stars and galaxies, NET affords clues about the building blocks of the universe. The telescope's capability to discover infrared mild unveils previously hidden areas of stars, our birth, cloaked in cosmic dust, dropping mild on the technique of famous person and planet formation. Webb's observations of celestial bodies within our very own solar machine, from Mars to the outer planets, enhance our understanding of their origins, atmospheres, and probably livable moons. The collaborative attempt behind the James Webb Space Telescope exemplifies the worldwide commitment to increasing our understanding and pushing the frontiers of area exploration. With each challenge, Webb is expected to rewrite textbooks, presenting new theories and fashions about the universe's age, composition, and development. The telescope's findings not only increase our understanding of the cosmos, but also inspire future generations of scientists, engineers, and dreamers to maintain exploring the unknown. As we stand on the brink of latest discoveries, the James Webb Space Telescope reminds us of the vastness of the universe and the small but large area humanity holds inside it. The legacy of the James Webb Space Telescope can be measured not simply in the statistics it gathers, but within the questions it activates us to ask about our universe and our vicinity within it. As we peer into the depths of space and time, NET's picks and discoveries are a testimony to human curiosity and our relentless pursuit of expertise. The James Webb Space Telescope, a surprise of engineering and science, is a beacon of hope for unraveling the mysteries of the cosmos, one photon at a time. Join us here. Enroll in our channel for more exciting area discoveries and updates on the James Webb Space Telescope's quest to get to the bottom of the mysteries of the universe. Stay curious and never stop exploring the infinite possibilities that lie beyond our planet.